Thank you everyone who has attended our first webinar. In this session, the second session, we are going to take the Q&A. We have a team of experts who is going to answer your queries. Now over to Dr. Gaurav Majumdar to moderate the session.
Okay, thank you, Alex, and welcome George and Lars and Alex for this Q&A session. This is because we had a lot of questions which were posed after the previous webinar on troubleshooting in the IVF lab, and we'd like to put the answers on record for all those questions for the benefit of the audience. So the first question that was posed by the audience, and perhaps George, you can start by answering it. The question was that, do you think that variable oxygen concentration below 5% and above 2% can lead to better blastulation?
So, of course, we all know the benefits of low oxygen culture in terms of better blastulation and more embryos being available for cryopreservation. So we have, and most of the IVF settings have a range of oxygen ranging from 5 to 7% of oxygen instead of atmospheric air. But there is limited data until now for ultra low oxygen levels. There is one randomized control trial that has compared 5 to 2%. That has shown that there is better blastulation with the 2%. However, the blastocysts that made it had significantly fewer cells than the blastocysts in the 5%, and also showed some alteration in the metabolites that are associated with homeostasis. So therefore, before implementing into the clinical setting, the 2% setting, a lot more studies are needed to verify whether that can actually be beneficial or not.
Okay, so as per you, this trend of ultra low oxygen has not caught on, and it has not been implemented into clinics, right?
In terms of our clinic, we're only using validated data that has shown effect that has been effective by randomized control trials. So until such studies are available to verify this, we don't want to take any chances with a system that works.
And I wanted to ask you one more question, that when we talk of 2% oxygen, does that mean that the nitrogen becomes higher?
So the nitrogen is used to balance the oxygen setting. So that is used correct to lower the oxygen.
Okay. So a higher nitrogen doesn't pose any problems for the embryos? Yeah,
I think that the physiological way of the embryo as it transverses from the fallopian tube to the uterus is to lower that oxygen level slightly. So this is where the 2%, the ultra low oxygen theory comes into place. However, in vitro, until such data is available to demonstrate the effectiveness of the ultra low oxygen, we're still waiting for those data to come before we implement that practice.
Lars, do you have a comment to make, please?
Yes, there's also, as we know, we have used low oxygen since, I don't know, 15 years. And, also that we're using small incubation versus the big ones. And we start already from egg collection. We have 5 to 6% variability. The problem with having more and more or lower oxygen is the quality of the nitrogen.
Mm-hmm.
So you pump in more nitrogen and you're going to lose a lot of money because you have to have it down to 2%, for instance. Mm-hmm. Then your costs and your gain, I'm not so convinced that you can do it in a clinical setting, and you need a lot of incubators. Okay. Because it's going to vary so much. So we haven't implemented that 2%. Following the same as George is saying.
All right, so that's a good take home. Alex?
Because all this concept of ultra low oxygen maybe came from early study by Barry Bavister in the animal models, because they have shown that in the fallopian tube, because that is early compaction, the embryo resides, where it is mostly it is oxidative phosphorylation. So they have shown that there is the oxygen concentration is around 5 to 7%, and when it comes to the uterine environment, it was only 1.5 to 1.75 percentage. Maybe that's the reason some groups started working on this area. So they thought that it is more physiological and maybe having less oxidative stress to the embryo when you put it in. But I think two studies that George has mentioned that didn't show much improvement at the practical level. But there is one clinical trial, I think, that is going on from 2015. I am not sure about what's outcome.
Mm-hmm.
So we have yet to see what is practicality of this scenario. Until then, I think we have to follow the standard protocol of 5% oxygen.
Yeah, I think it's for the time being, it's good to stick to the standard of care, which is 5% oxygen. The next question that was posed during the discussion was on troubleshooting poor fertilization rates in ICSI. So since George made a detailed presentation on that day, so I'd like you to quickly enlist the important points in doing so.
Gaurav, is it a good time to show that presentation, or should we just make the points and show that later?
Okay, we could show. Do you want me to show the presentation? Then just hang on for a second.
Yes.
I'll just bring those slides up.
So basically, the presentation is meant to show, first of all, how we identify that there is a problem, first of all, with the ICSI fertilization rates, and that is through the KBIs, and the way to construct control charts in order to be able to see that drop in how it is an effect that we should take an action. And then through troubleshooting, I'll talk a little bit about the Ishikawa fishbone diagrams, which is basically a tool that we use to input what we consider to be possible reasons, and then troubleshoot each one of those possible effects.
So George, would you like to talk about that specific example that you had mentioned, or?
So yes, so one specific example is if we have seen, for let's say that there was a drop in the fertilization rate. So we first start and examine the population to see whether there is a shift in patient population. So the first thing to see when there is a drop is, does that originate, for example, from a poorer sperm sample, and we do that. And if there is no reason, then we have to see the clinical features like the age, the stimulation, the previous history of the patient, so anything to do with the clinical characteristics. Once we establish that there's no problem with that, and of course we do that by proper statistical methods, then we have to check the competency of the staff. So is there a drop in stock performance? Is someone's ICSI results, for example, bringing the whole rate down, and is that the purpose? So we check each and every different practitioner, ICSI practitioner, or we see whether there is staff in training, and that might be the reason, to see whether there is someone that might need to be retrained. Once we see that there is no problem with that, then it is important to check the environment, of course. So especially when it comes to ICSI, it's very important to see the temperature of the heated stages and the culture conditions, of course, ranging from all these variables that we talked during the webinar, like the temperature, the pH, the air quality, the osmolarity, the gases, all can have an effect. So we need to look into each and every one of those parameters, and we need to use validated equipment that are calibrated and within their specifications for those parameters to establish whether there is an actual problem within those parameters. So in that example that I was saying, that we had a drop in the fertilization rates, We then we checked the gas, and the composition of the mixture was verified. We checked the air quality, and there was no difference in any of the characteristics and the sensors that we used. And we then moved on to see the toxicity from any of the plastic ware on the media. So we tested to see whether there was any introduction of new lots, and we saw that the drop of fertilization rates coincided with the introduction of a new lot of handling media. So even though we were not able to confirm directly the toxicity of that handling media, what we did was took a proactive step and replaced that lot with a new lot. And we saw that in the following few weeks, the fertilization rates bounced back. So this example, I wanted to demonstrate to issues that sometimes when we're talking about needles in a haystack, it might be that sometimes you might not even be able to see the needle in the haystack, but by a process of elimination, we can come to proof by contradiction.
That's very interesting. So I just would like to ask you again, the lot of the dish was changed or the needle?
The lot of the handling medium. So let's say the mops, if you're using mops or hippies, or some labs use bicarbonate. So it was one of the potential candidates that we used. So the introduction, when we saw the drop, we went back, and this is where it is very important to keep logs and all that information in databases, because you don't know where the solution sometimes might come from. So the more information, the more detailed the database, the more availability, and that information is easy to access, then the easier it is to pinpoint and try to find potential candidates of where the potential issue comes from.
But so can I also say that probably you guys got lucky also that you were able to pinpoint the exact component, because many a time probably one would not even be able to pinpoint, to the final degree.
You're correct, Gaurav, and this is what I was saying, that we were proactive because we did not know whether that was the issue in the first instance. But even a potential candidate, and something that even if it's just a coincidence, then you have to take those proactive steps, because you cannot wait until you test every single scenario in order to get those answers. Sometimes the answer might not come directly. Sometimes it could be that the issue resolves and you don't know what was the change that implicated. But the more input you have, the more available data, the more everyone is on top of their KPIs, the easier it is to identify the problems early on, the easier it is to take action, and the easier it is to be able to rescue things at the beginning, at the root.
All right. Thank you very much, George, for that.
No worries,
Very, very insightful dissection of the problem.
Hi, Gaurav, I have a comment on that.
Yes, please, Alex, go ahead.
I do agree with George. I had a similar kind of experience in a particular batch where the fertilization was low in both the IVF and the ICSI cases. And we could pinpoint to that same, like in a handling media. What we did after that, we did a sperm survival study in that particular handling media. So interestingly, within 1 or 2 hours, all the sperm were dead in that particular media. So that, especially this is very important, like especially in India, we have so many.
Alex, I'm thinking that when like George mentioned handling media like GMOPs. So I'm thinking that the same GMOPs is also being used for egg retrieval, for retrieving those same eggs, and for perhaps denudation of the eggs, and then performing ICSI. So if there were to be some problem with the handling media, then all those different steps would get affected. Am I correct?
Maybe I think that is not maybe kind of visible, because these are very sensitive area. The peri-fertilization period is very sensitive. And also, as I said, when we use the same thing for sperm preparation, the same thing came out about the toxicity was more revealed. That's why we could pinpoint. And especially in India, like there is so many sub-distributors are there. And if they don't maintain the temperature during the transit, especially in the customs, it might get delayed. By the time it reaches you, maybe it is in the coolant packet. Maybe we don't know how it was handled before that. So as a part of, even though there is MEA testing and all other testings are done from the manufacturers, some centers I know that they do in-house testing before they put it into action. So maybe especially since there are so many batch IVF centers, they put all the patients together. Maybe it is a good practice to do a sperm survival study before you start the batch of media for IVF.
And to tell you, I'll just make this comment and then Lars, you can take over. To tell you the truth, in real life practice, of all the people that I have heard, whenever there is a problem, somehow instinctively, the first gut reaction of everyone is to perhaps change the lot of culture media. You know, I understand that everything has to be looked into, and the way George described that you go from step A to B to C and then you go stepwise, but somehow in real life, that's what people tend to do, because they think that culture media is perhaps the most important and crucial variable, which is, you know, the game changer. Lars, what would you like to say?
Yeah, I would like just to comment what we have here in Scandinavia. We actually have softwares that we had for years and years because we implement single embryo transfers. So we have a lot of control, like George said. We have a software that we also have to send in yearly and get all the details. So patient can select the clinics. They can deduct which clinic it is, but the number of treatments. So they can actually know what the results are. And we actually cooperate. If someone have a problem, we call someone and ask, do you have a batch problem with this? No. And then you just go on. You can quickly solve it. And the other thing is, when you see a lot of problems with fertilization rates, I think it's a lot that I've seen has been the ICSI pipettes and how they manage, because I was manufacturing pipettes myself at Monash. And if you didn't do it in a proper way, you get small, what shall I say, residual glass, and they will lyse the eggs, destroy them. We didn't discuss about lysing, but also the time when you do the egg collections. And so the sperm, so the eggs will mature in a nice way. So they can be immature, but they are still, what shall we say, they have the spindle and everything, and they react in a different way. So when I was in a certain country, we had a lot of 3PNs. So the fertilization rates is also depending on how you take care of the semen sample from the beginning. And that has been just the thesis on it, what we're doing in the 90s, and we're still doing. We add media directly to the semen sample when it comes to prevent free radicals and also the preparation. And that thesis now has explained everything that we were doing, and it's about the osmolality.
Yeah, correct. So, but those are still things that people can get right. But what I understand from the discussion is that the performance of the procedure, the ICSI operator or the embryologist plays a crucial role too. And as George mentioned, that if the staff performance is a bit skewed, then retraining is very necessary. Because small things like sperm immobilization and injection and the amount of damage which is inflicted to the cytoplasm, these probably would matter in fertilization to occur.
Go for piezo. But also another thing that is very common in Asia is aliquoting of media in totally non-checked test tubes, and they produce a lot of toxins inside the media, and then you use it, and then you blame the companies, which I've been working for one of them, and you always go and troubleshoot this, and you can see immediately, okay, you're aliquoting and you're destroying the media.
All right. Okay, so now time to move on to the next question. this question was posed about whether in the present circumstances would a full-time in-house embryologist is preferred over a visiting embryologist. So everybody is welcome to put in their 2 cents.
Well, can I talk?
Yes, please, Lars.
Since I've been in India a lot, where you have a lot of motorbike embryologists
Yes.
going between the clinics and doing the ICSI, and then they have their own sort of staff that helps them to denude and everything, and then they just come in and do the ICSI. And when you have that, you're a lot of sort of, the others are not being taught properly. So you can't have, if you had an in-house embryologist, then you have a better control, I think. And of course, those that are visiting embryologists, they can be highly skilled, but you don't have the full control of the chain.
And
So I
especially
think,
because the question says that in present circumstances, so in present circumstances, having people fly out from other cities or and visit your center would be very
exactly
dangerous.
But you never know what you're going to experience next time.
Yeah.
So in-house, yes, I believe in that.
Yes, George.
I agree fully with Lars. The in-house embryologists will know the routines, will be familiarized with the processes. So always an in-house embryologist will know the patients, will know how to deal with situations, how to troubleshoot, how the equipment work. So those skills and the know-how, those cannot be brought from an external source most of the time. So this is very valuable.
I myself would think that probably it's very important for the embryologist to know the patients, the ins and outs of the patients, and which a visiting embryologist has no clue about. So it's important to have a good rapport with the clinical team and with the patients as well. So which is completely missing if a shadow embryologist or a visiting embryologist comes in. So now let's move to the next question. So this is settled that definitely an in-house embryologist would be much more valuable, especially in the present circumstances in comparison with a visiting team coming for IVF to your center. Now, the next question which was given was that, does the droplet size affect fertilization rate and embryo grade? So I believe the droplet here refers to the culture droplet.
Fertilization, it says.
Yeah, it also says fertilization, correct. So then they're doing fertilization in drops under oil, right?
So I think that we covered a lot of that during the webinar as well. So everything has to be taken into context with the effect of osmolarity and how that changes in the dish preparation method and how each lab has validated their methods for undertaking the fertilization under oil in droplets and the embryo cultures. Of course, there is minimum requirements like the minimum volume of media to be used, so it doesn't allow evaporation and reduction in osmolarity. So we know that you cannot go below 20-30 microliters when you're making your dishes. But also the dish preparation has to be done in a stable temperature in a laminar flow hood with the minimum setting of airflow on the cold stage, so not on the heated stage, by making only one dish at a time before overlaying in oil, and of course using good hygiene.
So George, do you do single embryo culture or group culture?
We do group culture. And we do the fertilization for us is in humidified incubators with not oil overlay. Of course, that doesn't mean that that's the correct method or whether different labs are using different methods. It comes down to validation of your individual method and your equipment and the know-how of how it affects the parameters in the lab and how good monitoring and how good quality control system you have in place.
Lars, what is the ideal drop size while culturing single embryos, in the mink incubators under oil?
Well, when it comes to mink, I used it the first ones, and then I gave up because of temperature problems. But I would say that what George mentioned about drop size, again, when you work in a class 2 bench and you do the drops, you do one dish at a time, but people still make many dishes and the osmolality is changed totally. But we had an incident in our hospital in the 94 or something like that. We were inseminating small drops. And then we also went into big drops. But she was putting, she thought, a 10 potence higher sperm, but she didn't. She actually had 10 less. So we inseminated with 10,000 sperm. And the quality of the embryos, fantastic. And the pregnancy rate, fantastic. So that number, you know, you're saying you're inseminating with a certain number. It's also how you pipe it. That's another thing I've seen in clinics. And when you do this, there is the group culture that we always had done, but now you have the time lapse. It's single, but it's huge drop. The closer you get them, actually when they're sitting together, that's group culture. So we have done that, and we have also done cumulus culture. So we have together with the oocytes, because when you do ICSI and denude them, you can take that and put it down there.
So for the
and it works fine.
So for the benefit of the audience, can you put numbers to that? Do you recommend a 20 microliter drop or a 30 microliter drop?
If you go between 20 to 40, I don't think it's going to be a big difference. But if you go even to the micro drops, like 2 microliters that we're using in Doha, Qatar a lot, I don't know, ultra drops, I think they were called. That's a problem with osmolality.
No, but what about group culture? Say if you want to
group culture,
3 or 4 embryos in one drop.
Well, if you have a smaller and you have control of your media and osmolality, I would go for 20. And we have like 20, 30. So at the moment, it's like 30.
30 microliters.
Yeah, and we have group culture.
For how many embryos?
When we have denuded them and we have, if we have 5, we can put 5 in one of those drops. Okay. And we see that we have good blastocysts also. But now we're getting into more of time lapse. And so we use mean incubators, the BT37, C37, and then time lapse.
Okay. So what I understand is that what is most important is just dish preparation while making drops. And the smaller the drops, the better the control has to be while making the dishes.
Oh, yes. And the other thing is that I see that they don't use the proper pipettes when they're taking the media. You take, you have prepared everything, and then you suddenly have a pipette that is not tested, pipette tip, and you don't have a filter tip.
Okay, so pipette.
Then you put the
very important. Alex,
I would say that it's.
Yeah, George. Okay, continue.
Please go ahead.
I'll come in after you.
I think it doesn't cost a lot. It's an important investment in an automatic pipetter, because it's much faster than an individual in terms of the making of the dishes. It's controlled, it's validated. Of course, you're gonna have it calibrated, send it to an external authority to make sure that the volumes are accurate on a yearly basis, but it saves a lot of time in the dish preparation, and that time is not for the time of the embryologist, for the time that osmolarity can change.
Yeah, that's a great point. Having an auto pipetter or even a I don't know whether a multi-pipette would work here. Well, at least the auto pipetter would save a lot of time and would save a lot of bottle opening and prevent the osmolarity from changing. Alex, you wanted to say something?
Yeah, when it comes to the dish preparation or the droplet size, there are some variations. Some people uses maybe 7, 10 or 20, 30, even up to maybe 0.5 ml. That all should depend on the type of environment that you are. If you are okay with if you have a proper clean room area where you are working, and if you are well confident with your culture system environment, it's true that you can go with the micro droplet or the droplet culture system. But otherwise, if you talk about the Indian scenario where many cities have high pollutions and proper AHU is not properly installed, Even if there is a HU, you don't have the proper ventilation system for the VOCs. And many centers still use large box incubators, 150-liter large box incubators, which I think 95% of the air is taken from the laboratory air. In that scenario, you are accumulating all the contaminants or the VOC into a small vicinity of 20 or 30 microliter. So in this scenario, I always propose to culture in maybe 0.5 or 0.6 ml covered with oil in the forward dish, so that there will be some kind of a dilution effect of the toxicants. That's a practical point I can tell to my colleagues who are working in many Southeast Asian countries.
That's very useful, and that brings us back to the point that we should not blindly follow any form of advice which works for other people, because you have to make sure that it's working and it gets validated in your own system. And I myself know of many laboratories, big laboratories, and even labs in the UK and Europe, where they're actually doing cultures in large volumes, sometimes with or without oil, because it works for them. That's what works for them.
Well, you can look in their single embryo transfer technique, or the percentage if they have that, because you can compensate for bad culturing by putting back a lot of embryos. And there you see in the implantation rate.
I'm sure they don't put too many embryos, then the whole purpose is lost if you do that.
Yes,
But
you know, we can do fetal reduction in some countries, but we are not allowed. That's why we also have around the 95% to 97% single embryo transfer. We're not allowed.
Mm-hmm. No, that's great. We ourselves, our laboratory, and I am in New Delhi, and we are a big laboratory. We handle about 1,200 pickups a year.
Oh,
and we, being in India, something which is not easily believable. In the last year, out of about the 800 FETs that we performed, 75% of them were single embryo transfers. So, and we are striving every day towards single embryo transfer, because we understand how much problems we are creating by transferring, by giving rise to multiples.
yeah.
And our clinicians get to face the flak there. And now we understand that transferring multiple embryos doesn't necessarily increase the outcomes. It may only affect them in a wrong way. So having said that, let's now the next question, probably Lars, you can take. It's about positive pressure. Is it recommended in the operation theater during especially the COVID period?
Well, I hope you don't have any COVID patient and you check them before anything is undertaken. But, you know, I would say the positive pressure should be in the laboratory.
Okay.
Towards the operation theater, because the operation theater, if you measure, it's one of the dirtiest places compared to the lab or the cryo room or whatever. It's extremely dirty. And you get surprised what you can find there. But if you have the ventilation there also, they have shown that if you have a higher pressure inside the lab towards the OR and a little bit lower there, so it goes out, all the dirt, then you also have less chance of getting the infections. But we usually don't have these kind of infection. If we have any infection, we get really surprised. But when it comes to viruses, then you have to have a really good ventilation.
Why this question is very important is because majority of the labs in India do not have positive pressure.
Exactly.
They do not.
No,
so
I know.
So now, yeah, you know this. We know this.
Yeah, I've seen so many.
Right, there are.
Yeah.
And probably across the world, a lot of places do not have positive pressure. So now does it become very important to actually go ahead and consider getting a positive pressure in your laboratory?
Yes, it has always been important. And we implemented it, that's 15 years ago. So we have had it all the time, but we haven't had maybe the quality of the air that is needed. And when you have a quality in the air, you will see also better results. And it's very important. You know, it's not only about the ventilation, it's also how the staff are dressing, what disposables you're using, everything.
Everything.
And I have,
But regarding positive pressure, George and Alex, do you think that now is a time when it becomes mandatory for someone to go and actually get it?
Yeah, I will go with the same opinion what Lars mentioned. It is not only for the COVID time, because the positive pressure is of utmost importance for the IVF scenario. That can keep away all the toxicants or the particulate matter from entering into the laboratory. I think that should be implemented. That is one of the special thing, one of the thing that is mentioned in the Cairo consensus. I think it's going to be around 30 Pascal or something like that. If I'm wrong,
yeah, the problem is that the Cairo consensus says 38 to 50 Pascal. And that is like you're standing in the wind and working with cooling embryos, and you can't have it. You can't even open the doors. But around 30 Pascal, that's enough. And how you build the ventilation and where you have the inlets and so on. But you now have a spreading a possibility, so you don't have to be scared about the problems with ICSI equipment and so on.
You know, this is the problem. I have actually been in labs where they have positive pressure, and they are scared of switching it on, because when you switch it on, it feels as if there's a strong wind blowing, and somehow we're not tuned to work with such strong winds blowing in the laboratory, and it's constantly psyching us out that it's raising the temperature of the embryos. So it's one thing to say in theory, in Cairo consensus, they can go ahead and mention any amount of pascals that they want to, that 38 to 50 pascals is recommended, but how does it translate into real life application?
But you see, it doesn't become like you're in a storm with 30 Pascal, not at all. Because you have a reduction in the Pascal towards the OR and also to the pre-entry room and so on. So your inner, the heart, so to speak, of the laboratory, it's under a little bit higher pressure, but we don't react to it at all. Okay. It's not like it's windy outside.
George, you want to say something? George.
I just, I think both Lars and Alex covered the positive pressure. It's just the comment that about the question was addressed whether positive pressure is recommended in the operating theater during COVID.
Yeah.
Just because in hospital settings, the positive pressure can be easily turned to negative pressure. And sometimes because the COVID itself is related to airborne generation of aerosols, it could be that for procedures that generate aerosols, you could turn then the operating theater into negative pressure. I would say that that is an important not to do, especially if you, for example, you have a flow hood where you collect the eggs directly in there. And if you have a negative pressure, that could basically drive all the aerosols towards where the eggs are sitting and where the hood is. So that's also very important.
Can I comment there? Because, when it was HIV and all that stuff, you had this negative pressure, so everything stays inside in that area where you're working. And many are building those, and they thought they're gonna take all these patients. And then it was like, when you always have a new thing, it goes up, a lot of patients, then it disappears. There's no one left. So you're standing there with a special laboratory that you can't use for anything else then. So that I've seen also in countries.
All right. Okay, so should we move on to the next question now? So this question was again posed to all panelists, and it stated that we culture oocytes for at least 3 hours before inseminating them. So the question goes that the days of stimulation and the type of trigger is crucial in achieving the required cytoplasmic maturity of oocytes. So in your experience, in terms of days and lead follicle size, what would give you the best results? So this is a question related to stimulation having an effect on oocyte quality in terms of cytoplasmic maturity.
I have no comment on it because I'm not a clinician, but I can see the consequences when you get the eggs, the cumulus offers, when they come out. You can say, uh-oh, something's wrong with the stimulation here.
Okay.
Or it could be just because it's certain patient. So I wouldn't pinpoint on any specifics, but again, the clinician should answer that question.
George, what do you follow in your center?
It varies. I mean, we use different cycles, and every clinician will take the investigations of their patients and decide on the stimulation regime and the protocols they use. So it varies a lot between individual fertility specialists. But usually what the expectation would be that if you have a greater than 18 millimeter follicle, and of course the accompanied bloods to show that the estradiol levels are within the levels, then you program the trigger, and then follicles usually between 12 and 19 millimeters, you would expect to get a mature oocyte from those, but it doesn't always work like that.
It doesn't.
No.
Yeah. So there's a lot of variability. Alex, yeah.
Yeah, there can be variability because the conventional kind of stimulation and trigger used to be when the mature follicle, at least 1 or 2, reaches 80 millimeter, the trigger is given, the trigger is given. But one of the things that has changed over the years is that people try to avoid that leading follicle, maybe let it grow for maybe further 18 millimeter to maybe 20, 21, 22, doesn't care. They look at the cohort that is coming from behind so that you can save a lot of follicles. And this kind of situation, maybe you will get a more mature, cytoplasmically mature oocytes. You don't have to wait much time, because otherwise especially if your days of stimulation are also less, maybe that also varies. Some people give the trigger maybe by 7 day or 8 day, 9 day, that even go up to maybe 12 or 13 days. So that is also can have an impact on the final maturation. So even if you get the M2 sites, there can be some kind of cytoplasmic immaturity. So as the questioner has asked, maybe 2 or 3 hours of incubation, the post-retrieval is warranted. I think that can give some kind of cytoplasmic maturation.
Okay. Yes, Lars.
Now we actually have meetings every day with all the doctors and the embryologist for like 20 minutes. We take a cup of coffee, and at the same time we have a software. We can see all the stimulations and everyone can comment. And then we also can say what day it fits where we can do the egg collection. So we have a very open mind, and we are not sort of sitting there on our big chairs and saying, no, we have to do this and we have to do no. And if we do introduce anything new, it has to be valid properly. The other thing about this leading follicle is that if you get the leading follicle, that's the best one. So if you avoid it, you get the other things coming afterwards, and it's not good. And we have seen it before. We call them, when we see that have not taken the leading follicles, we see that they continue. We call them the leopards because they look like an egg with a lot of clumps around it, dark clumps. We can say, oh, you changed the stimulation. So.
All right. So that was a lot on stimulation. And we know that stimulation can have its effects on egg quality, but it's there's a lot of space for variation over there. The next question talks about getting medical gas, medical grade CO2 gas in India. So how to manage it? Yes, Lars.
Yeah, well, it's so expensive, medical grade
Is
gas
it
in
necessary?
India.
Is it
In India.
necessary? First,
Yes,
is it
because you
necessary?
have residues of toxins inside. You have benzene and a lot of other stuff. I had a long list on it. And the quality of the gas is important because it's going into your incubators.
So
But
Alex and George, you also agree that medical grade CO2 is absolutely necessary?
Yeah, definitely, because that's, but unfortunately, I have doubt whether we get a medical grade gas in India, whether we have that kind of a certification.
Whether you even have it, yeah.
Yeah, because I have a lot of experience on multiple centers when I was doing the embryology consultations. So many people get the gases from the local vendors. That is one of the big issue. I think only a few companies give us some kind of a good grade of.
So what are the things we are supposed to look for when we are procuring gas from any company in India? What are the important things?
The first thing is the kind of a cylinder, whether they are exclusively using for the medical purposes. I think that's the only thing that people follow in India. The second thing is that the certification, the gas quality, that need to be taken care of, what kind of toxicants present. But the problem is that you have to ask them for the certification. Then only they will do it. Otherwise, I'm not sure how many companies are giving the right kind of information to you. Maybe you have to sit across the company manager who is supplying the thing, and you have to tell them your requirement. Especially this become more important when you are using the tri-gas mixers.
Yes.
Because many people are using the mink type of incubators where you have the set kind of concentration of gases are supplied by the company. If you don't know the quality of the gases, I think you are putting your embryos in jeopardy. I think that is very important. And one more thing.
Alex, yeah, okay, go ahead.
Yeah, one more thing. I think in one of the review, Dean Morbach has suggested the best thing would be to go with the benchtop incubators. In that scenario, you are not exposing your culture dishes to the laboratory environment, because all the gases or the air that is surrounding your dish coming from your cylinders, especially if it is a kind of a water bath is there, it bubble through that and this get into that system with a humidified environment. So in that scenario also, the gas quality is very much important. And I have seen in many places in India, the early miscarriages, so blighted ovum, all this kind of problem can be attributed to the kind of a gas that they are getting. Even I have seen in some centers, even if they put an inline filter, either Coda or Sperm, what kind of filter, even they get a total wash away of the batches. They get biochemical pregnancies.
Oh, you mean that the filter is faulty?
Filter, yeah, filter. No, even they put the filter, that is not enough to hold the toxicants. They cannot filter the toxicants. So one has to be very careful about the. I think George has some kind of comments.
Yeah. George, what do you?
I think that if you're not able to retrieve certificates from the gas company to clarify the purity and specifications in compliance to the international standards, then maybe it's worth to get new cylinders that company can use directly from you. So you know at least that those cylinders have not been used for anything else, and they don't carry any toxic and residue from other material that they have been used. Okay. And I think it's also very important to, like, especially if you're using a mixed gas, to validate each one of those cylinders, what they contain. It could be that they say 5% oxygen, but it could be atmospheric air in those. So it's very important to get a gas analyzer and test it. Either if your incubator has a sensor that can measure it, or if not, go directly to the cylinder, get a pressure reduction regulator. But before you take the reading, always get a standard gas that you have validated the measures for, to make sure that you first calibrate. You know that, for example, you have a standard gas of 5%, you get the 5%, then you test the cylinder directly before you put it into the circulation.
So that's a very good suggestion, right? So we need to validate. So if we do not trust the certification, and if the company cannot provide that kind of certification which is required as per international standards, then it wouldn't hurt to have a gas analyzer and just check the CO2 concentration and the oxygen concentration before actually putting the cylinder in, because that cylinder is going to last for a couple of months or more, and you're going to culture your patient embryos in that. Yes, Lars.
Yeah, well, I would comment on that because I put up a lot of clinics, and the accuracy of a mixed gas, if you put it on 6.0, you have 5.9 or 6.1. That's the closest accuracy you can have. And how it affects pH is very, very small changes. The other thing is when you have humidifiers, I see that people are not changing the waters and not changing the bottles. They top up. So you accumulate more and more toxins in that water. You must change it.
Okay.
That's very important. They don't do it. When it comes to very bad gas quality, there are filters that can take it away, but they don't change the filters. And the charcoal, I said that on the previous meeting, that it holds it for some time, but when it gets oversaturated, it will release everything. But now there's a new kid on the block that takes all it away. And it will come to India.
And it is, is it?
Yeah, we have been done a lot of tests and it's fantastic.
Okay. All right. So, but in the meantime, it would help to check the gas, because you're talking about 6% being, shown as 5.9 or 6.1. I have seen 6% being read as 4.5 on these while checking them with a CO2 sensor. All right. So now.
Guru, I have one kind of comment on this.
Yeah.
I have a suggestion to the clinics, especially in India, which are established in the suburban areas or in the smaller town. What they can do is that they can speak to the vendors from there, both the incubators. Maybe I think they can suggest from where they can procure the good quality gases. Because in India, I think there are only 2 or 3 companies they provide the so-called best quality gases for the purpose. Yeah.
Yeah. All right. So that was quite a lot on the importance of gas and how to troubleshoot problems associated with it. Now we had another question on, again, the droplet size that we've talked a lot about. And then there's a question on fertilization rates for ICSI. So this is a question which says that what are the ideal fertilization rates for ICSI? Well, we know as per the Vienna consensus, where they've given competence values as well as benchmark values. So they slightly differ between IVF and ICSI. So George, what are the benchmark values for ICSI fertilization?
So as per the Vienna, I think the competence is at 65 and benchmarking is 75. But of course, every clinic has to see the fertilization rates into perspective to their own practice.
Okay.
So if, for example, a clinic has ICSI fertilization rate less than that, it could be an outcome of many, many things. And I think that's what we're going to talk in that short presentation later on.
All right.
But for an example in how you can resolve fertilization rates, for example, let's say that you have a group and they're all performing at the same level and is lower fertilization. Sometimes bringing in an experienced embryologist can lift the game for the rest of the team as well. So it could be that because everyone learns from each other. And let's say you have a group of embryologists, but all of their competences sits low and you are in a very controlled laboratory, then it could be the performance of everyone is compromised. Sometimes it doesn't necessarily mean that if everyone sits at the same level, it definitely has nothing to do with the human parameter. So that's just another idea of what can possibly.
But it's important. I think this gives us a good direction that 65% is something that everyone should be able to achieve, because it's defining competence. And then benchmarking is something that you have to work slowly, and it's a part of quality assurance and improvement. And yeah, what you say, that you may require new people, new perspectives to come in and perhaps lift the game for everyone. Lars.
Yeah, I don't think you should compare against your neighbor or the clinics you're competing with. You should go more international and think higher. But for instance, in China, where I was surprised, they had 90% fertilization rates. And then I realized what we're doing. They do most of the cases IVF, and then they wait 6 hours, look for the polar bodies, and then they do rescue ICSI on IVF. And the results, I couldn't understand why they had so good results all the time in fertilization. And they have a law, so they say they must do at least 30% IVF.
Because they're not allowed to do ICSI for non-indicated cases. They have a law in place.
Yeah.
All right. So, so George, you will take up fertilization in a couple of, after we finish these questions, and then you'd like to show some slides pertaining to fertilization specifics. Now, we had another question which was answered during the webinar about the time interval between thaw and transfer of frozen blastocysts. So we will not take that. And we also answered the question regarding fertilization rates. They drop in non-resistant oocytes during ICSI. So we spoke about that. So we can probably take this question about benchtop and real-time incubators. Are they now mandatory? Yeah, so the question is that are benchtop or real-time? I believe real-time incubators is time-lapse. Yeah.
Yes.
Do they become mandatory now in today's scenario?
Can I?
Yeah. Lars.
Okay. No, I mean, benchtops, they've been here for a long, long time. And if you want to have a good recovery, good environment inside, then you need benchtop. But if you have one benchtop and you have 1,000, I mean, you can't open them up. It's going to have the same problem. So you have to have several of them. So we had many, many of them. But then you came with the time lapse, and that is a sealed incubator, you can say, where you do long-term cultures. And I also feel that if you can't afford time lapse, and there are some studies comparing benchtop against time lapse, and they say that they get the same results. So some are stating that they even get better with benchtop. But at the same time, time lapse is a very good learning, and you have complete control, and that is very nice to see and compare. You can see that bad embryos can become beautiful blastocysts, and vice versa. Good embryos can be lousy blastocysts. So I think they're here to stay, but can we afford it? That's the problem.
Okay, George, what do you think? That would you prefer to have one time-lapse incubator in your laboratory, or instead of having one time-lapse, have probably 6 benchtop incubators in the same cost?
I think it all comes down to cost, volume, practicality, usefulness. So all of the above need to be calculated for different settings. So of course, if you can afford the time lapse, it offers a lot of benefits, as Lars has mentioned. So those are not necessarily reflected. I mean, the latest in terms of the Cochrane library evidence using 3,000 couples and 9 randomized trials for 3,000 infertile couples does not show evidence of improved live birth rates, miscarriage. So any clinical features did not show to have difference. But the usefulness of having a time-lapse system in your clinic, it offers a lot of advantages. The cost, however, to benefit ratio is what needs to be calculated. If you cannot afford to have all your patients within time-lapse incubators, definitely, as Lars said, having it as a learning resource, at least cover a proportion of your embryos, or for example, patients that you think that might have a poorer developmental outcome and you need to observe them more closely, or you know that they had a poorer history and therefore you take that into account, or for patients that they had previous cycles and for some reason you can see you have lost the fertilization because of an early or late appearance and disappearance of PNs respectively. So definitely there is benefits, and if you cannot afford to get all your patients covered by the time-lapse system, it can be on a need for the patient. So taking into individual characteristics and who needs it and who would benefit from using it.
Okay. Yeah, Alex, please make your comment.
Look at the question that whether it is a mandatory the time lapse or the benchtop incubators. But when you talk about from the perspective of the embryos, I think you have to give the optimal culture condition. That is very important. And all the studies, I think many studies have been done comparing between the benchtop versus the box incubators, and it was shown that the benchtop gives a better kind of a blastocyst and the outcomes. Definitely, I will go with the benchtop incubators, and if the clinic can afford that, the cost is another implication. In our case, our Canadian clinic, we implemented exclusive time-lapse cultures from middle of 2017, because in Ontario, we have a one cycle of funding, free cycle covered by the government. And what we have seen is that until then, we were the benchtop incubators, and every day, from fertilization day 5 to 6, we were taking out the embryo for the scoring purpose. And when we shifted to the time-lapse system, what we have seen is that we are getting more kind of a blasto quality, especially the trophectoderm quality has been improved very much. I think that is the area, that epithelial, that pattern. You get a more kind of apoptotic spots when you are taking it every day when you take it to the X-ray microscope for scoring. I think when we stop that and when we culture continuously, we have seen this difference, and we got a more kind of a good quality A, B, BA blastocyst even by day 4 evening or day 5 mornings. I think that is one of the advantage. That all depend on the cost effectiveness and cost factors. Yeah.
All right. Yeah, Lars.
A short comment. In Sydney, when you used the first kind of mink, they were only scoring every second day, and they have much better results immediately. So if you leave them untouched, if you dare to leave them untouched, you can actually also get good results with the benchtops.
Yeah, we do that. We score them every second day, and sometimes we can even if we score them on day 2, then depending on embryo quality, we can then the next look that the next time when we take a look at them is on day 5. And
the other comment is that if you have a time lapse and you have to fill those dishes, you have to also do that in a proper way. Otherwise, you have damaged the whole culture.
So, all right. So, okay, moving ahead from time lapse now. So we have 2 more questions to go. So one is about culture media. So the question states that culture media is a major variable sometimes, or something that we were discussing before this. Like gas, it is very crucial, and I would request all panelists to make a short comment on what they think about culture media and how to control this variable. And the question also asks, which is the preferred media by the panelists?
Funny. I can start because I have to go soon.
Yes.
The thing is that you can have good culture in any kind of media, but how you treat the media when you get it, that's the biggest problem, and how you contaminate it. Because I see this when you just open a big bottle and you have a huge bottle and you use the same for a very long time until it's almost expired. And what do you think if you have a bad pipette? I'm coming back to that again, and how you work. Then you have destroyed it, and you will see the decline in pregnancy rate. It's nothing to do with the media, because this company has spent millions and millions of dollars in evaluation of the single vial. So every time I've been out doing these audits, I found that it's totally something else. So
what you think is very important is the repeated pipetting from
Yeah, like George said,
What?
we had always this multi pipettes. So you fill it and then tuck, 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 oil.
Okay.
So the quicker, the better.
Yeah. George, do you have any comment about storing the culture media in a certain way?
Storing the culture media is always in a pharmaceutical fridge. I mean, you cannot use a kitchen fridge or a conventional fridge because there is a huge variation between shelf to shelf. I mean, the pharmaceutical fridge works in a way that the circulatory fan allows, and the wire shelves around the temperature to be evenly distributed. It is important also not to overstack the fridge. So of course we all have the needs to have the same lots and monitor all the media and not place orders every other week and all that to keep in line. But we have to make sure that we're not overstacking the fridge, because that can also create some variable in terms of the temperature.
Okay. And Alex, do you have anything about how to transport culture media? Does that have an effect on media quality?
Yeah, definitely that, because in India, most of the media comes from either United States or Europe or Australian side. So once it comes to we know that most of the top companies take care of the customs clearance, but we don't know how much time it is spent in their warehouse. And after they take out, by the time it reaches different corners of India, you don't know what kind of transportation courier services they are using, but we don't have a temperature logger when it comes to your clinic. That practice is not there. So when it reaches you again, I have seen in some centers.
So should we ask for a temperature logger then? Should we make sure that the company provides?
I think maybe Lars can comment whether any other countries in Europe how they do.
Lars, do you have temperature loggers in your countries?
We have a tracer, you can call it, and the companies log them, so you can get the sort of a list to see what's happening during the whole transport. It's no problem. And the biggest problem when it comes to oil is that people are not storing it properly in the dark and in a cool area. They say, oh, we buy 5 liters and we put it on the shelves in the room, and that you get POV. So that is also a big problem because many are using microdrops, but the oil, you don't care so much about the oil, and it could make a major problem.
Okay. Yeah. And George, do you get temperature loggers in your consignment?
We do get in every media batch, yes. So then we send it back to the company, and then you're able to see whether there was a variation. Okay. I mean, that's for quality assurance purposes, to make sure that from door to door there hasn't been any change that can affect the quality of and the stability of the media.
Okay, and now one final question, short answer from all three of you. In this day and age, we know that there are brands of media which are being used across the globe, right? So they are now universal brands. We hear about them, we talk about them. They've become freely available in all countries. We know they are reputed brands where huge amounts of money is being spent in quality control. Now, do we need to do any form of in-house testing in big batches of media before we use them, or is it not required? Yes,
since I've been working in this field, I don't think it should be required. You should require from the company that they have done all the quality tests. Mm-hmm. But you know, this MIA test, you can culture, I mean, hybrids. I've been working with mice. They grow in anything. And then you have a lot of other tests. I'm missing one test, and that is the VOCs. There's no one doing VOC measurements.
Okay. In culture media?
Yeah.
Okay.
Why?
Mm-hmm. And George, do you do any form of sperm survival tests, or again, any MEAs, or do you completely trust the certificate of analysis which comes with your media?
I mean, if you use a media provider, you have to first use the provider that shows a good track record in terms of their results and their performance, and is someone that you trust and you have used. If you're thinking about switching media providers, then you have to, of course, test whether it's able to reproduce your result that you're experiencing within your system. So then you will have to study that media. Of course, testing each batch in terms of pH is something that would be a good idea to do in every new lot, to test the pH.
Okay. Okay. All right. That's good advice. How
Another
would you...
comment.
Yes. Yes. Okay, Lars.
When you change gas cylinders, you should also test the pH.
Correct.
Correct. Correct. So how would you test for pH? Alex, what is the best method?
Yeah, there are different methods to do the pH checking. That's one of the area that many people, I think, misses. They totally depend on the CO2 analyzer, or they depend on the digital display that is given on the incubators. I think whenever each media comes, a new batch comes, you should look into the certificate of analysis, because each lot might have a slight variation in the pH that they have tested with their kind of CO2. Some people are tested with 5% CO2, some people tested with 6% CO2 that you can see in the certificate of analysis. But when it comes to your own application, I think there are different systems that you can use. The simplest thing is that benchtop pH meters, but I think it's a three buffer calibration. That is one of the things. Second thing, nowadays you get portable blood gas analyzers. We use that thing for the, but you have to make sure that if it has become a little bit old, it will take maybe more time, maybe 2 or 3 minutes. I think you have to check that point also when you're doing the blood gas analyzer. If you have in-house, I think that's one of the best investment. And now the third one is that now you get online analyzers. You have a safe sensor we are using in our Canadian clinic. That's one of the, we have validated it with the blood gas analyzer. So it continuously monitor your pH for continuously for 7 days. One good thing is that suppose you are using a benchtop incubator with a mixed gas, and you have no idea what is the inside CO2 in the midnight or something. If any, if there is a blockage in your bottle, you won't come to know. But if you have this kind of system, online system associated with you, maybe you can see the spike in the change in the pH. I think this way, I think a lot of things are coming out on the pH. I think that's one of the vital thing, because pHI of the oocyte and embryo has very narrow range. If you change too much of pHE, external pH, the oocyte and embryo cannot kind of come back to or regulate that pH properly.
All right. So, so that tells us that pH is perhaps very critical and must be checked in your culture media rather than performing other tests. So, performing a pH check will come in very handy. So, all right. So, we finished the questions that were posed to us during the webinar. Most of the other questions were either on COVID, and most of them were answered during the webinar. So now. Perhaps I can ask Alex to take over and ask a couple of questions, and then we can finish with George showing his slides.
So now for the first question, that's a little bit towards the human factor related question in the quality assurance. That is to everyone. Is your place a learning organization? Why or why not your views on the teamwork? Suppose you know that if you have something new things coming, there is some kind of a lethargy maybe among some of the seniors. Why you want to implement the new technology? We want to be in our comfort level. So there are a lot of areas like that. Maybe I would like to take your views on that, the proper kind of function of the IVF laboratory and for the better organizational level. Maybe I will start with George.
Interesting question, Alex. I would say that yes, you're correct in terms that sometimes as people we're resistant to change, but change is not necessarily a bad thing, because we have to always strive to do better. And even if we're performing really well and we think that we're performing really well, there's always room for improvement, and that's what we should always strive for. And either is through encouraging our colleagues and giving them some ability to grow. So it has to be a learning organization in terms of developing the ability of staff to grow further, to understand the science behind, not just technicians that will do what requires to be done in terms of A to B and follow protocols, but understand and get education and learn, so we can always strive for better and reach more benchmarking levels.
Lars, do you have any comments?
Yeah, I think, you know, I learned so much by going to different worlds and different possibilities people have. And they have sort of invented stuff already that we don't have maybe in Europe, and smart things on the same problem, and they have solved it. And I feel there's always, should be always possibilities to do new studies. And if someone comes up with some idea that you think is really strange, when you start thinking and you start discussing it, you get more and more sort of, maybe not so stupid after all, because that's how new findings comes, new techniques, new products that you never thought of, because you get indoctrinated in your own small environment where you're sitting all too long. So I think actually it's very interesting to find new stuff, and you should always be open-minded about new techniques and so on. And people are getting too rigid, and because they are a sort of inner circle, and then you're not thinking outside the box. But you know, this academic hospital that I was working at, there it's also educational facility. So many are coming there, and we come from a lot of different backgrounds, and it's fantastic.
Okay. Gaurav, your views, because you are managing a huge number of cases and a lot of staff in your organization. So what are your views in your...
we are also, we are situated in a teaching hospital, and we have you know, fellows in reproductive medicine. We have now fellows from the Indian Fertility Society. So we have 2 embryologist fellows, and we have 4 reproductive medicine fellows in our department. So we have been a teaching hospital from day one. So our laboratory and our center is like an open book for everyone. And we are very transparent. And we think that, you know, by teaching and disseminating what we are doing and our knowledge, that's the only way to learn. And I think learning is a key. It is an absolute key to improvement, and you know, seeing other people work and interacting with people and learning new techniques and then implementing them in your laboratory. One has to be very, very motivated and proactive. And, you know, that's the key to success and improvement, constant improvement. That's the only way.
Yeah, I do agree with the Gaurav, especially the knowledge sharing between the seniors and the juniors and incoming trainees. That's a way our, the discipline, our IVF, that's a very complex area that can develop to the next generations. And this is a slide that I took from Julius Rinson. Now he's a lab director at Mount Sinai in Toronto, from one of his chapters. So they have put, he has put the organization to 2, low ability and high ability with regard to the organization ability to learn and improve its processes. So there are so many areas we can improve, especially one has to be very compassionate, more compassionate about the juniors and the team members. I think these are the important points to be considered. So let us go to the next point. I think that's very valid on the temperature maintenance. You know that it's very important. There's a lot of 2 different school of thought, maybe like on lab director in the US, I forget his name, in Texas. I think he had mentioned in one program, they were handling everything at the room temperature, not the embryo pre-implantation. They got the similar result. But we know that with the spindle systems and everything, there's a lot of negative effect of the temperature. So what are the best tools? Is it a thermocouple, temperature mapping, thermal imaging? And what are the key areas of caution to all of these areas when it comes to the laboratory? Lars, you can start.
Yeah, I only have 5 minutes now. Oof, next meeting. Actually, what we have is, or we had, is a software, and we have control of especially incubators and liquid nitrogen tanks and so on. It's on the 24-hour surveillance system. When it comes to surfaces, so we have also special QA people that comes and check it out. So we don't have to do it ourselves. When it comes to temperature mapping with thermal images, if you don't have the accuracy of them, they will give you different colors, and you can do mistakes on that. But how to calibrate equipment, that's special people for it. I've been doing it for many, many years, and it's heartbreaking. It takes forever because people are doing it too, what shall we say, too short and too quick, and with the wrong thermocouples. The cables and all that stuff they are using are not accurate. And I can even today see certain people when they come in and do the checking that they have the wrong, what shall we say, they have a very sensitive probe, but the machine they're measuring with is not having the same range. And that doesn't work. So, and some areas are more sensitive than others, like when you do the denudation and the ICSI, for instance, or when you do the warming up of after vitrification, etc., etc. And you have to have control of this, otherwise your results are gradually drifting.
So is it better to depend on the third party for your temperature kind of checking for the laboratory, or you should have your own temperature probe in laboratory? Which is better?
We have actually educated staff from the hospital that belongs specialized in the IVF. So they have all the tools, they have all the backgrounds, and we talk whenever we have any problems. They are coming to measure everything. But of course, because you can also have probes sitting there all the time in sensitive areas.
We have invested in our own tools because we don't have a third-party quality control, company looking after. So we thought that it's best to, rather than rely on other people to come and occasionally test, have at least some of the probes which are necessary in the lab.
Yeah. But one thing is that the calibration of your equipment is also very necessary. Yeah. Maybe every 6 months or every year with the properly calibrated system. George, because QC is one of your key interest area of your interest, can you put more light on this? Can you unmute?
Apologies, sorry. So for critical equipment, it's important, and we do as Lars does in the laboratory as well. So we have continuous monitoring throughout, so that can give peace of mind as well as in out of hours and with alarm relays connected. So if there is a drop, you can set the drop to a certain degree that someone will be notified and then action will be taken. But in terms of the thermal state for the temperature mapping, of course, you need to have a thermocouple device, and the right probe is very important. But it's also not just having the right probe, it's also measuring within the exact same conditions that you are performing the activity. So let's say you want to test your heated stage after you have validated your thermocouple with your microprobe. You have to set it exactly in the exact same conditions. So the type of dish, the drop size, the oil you're using, because different dishes, different oil overlay will have different variants of that temperature. So it's important to validate it to the exact same conditions. And it's the temperature within the drop that should be the one that defines 37 degrees.
Yeah, a quick comment is that there are now heat stages that are having many sensors, and they go and check back and forth, and they give you a more uniform temperature.
Okay. So George, I have a question, like when you purchase a new benchtop incubator, is it better to go for a thermal mapping at the different spots of your the plate, the heat plate, or is a single point mapping is okay, or what do you say?
I have not used thermal imaging before, Alex, so I cannot answer
No, I
that
was talking
question.
about the temperature mapping.
Temperature mapping, yes. Temperature mapping, we will test all the different areas that we would put the dish, and the exact same way that we're making the dish. So the thickness of the dish is different sometimes depending on what type of dish you're using. So then we will test all different areas, and it could be that in certain incubators you might find that some areas might need to be recorded as do not use because of temperature variation. So if you identify any of those areas, then absolutely you have to mark as safe to use or not safe to use.
Yeah. So the take-home point is that either you should have, it is best to have your in-house temperature monitoring system. It can be maybe online system, or you have a handheld system. But make sure that you do the calibration, proper calibration of your device every 6 months or a year. Or if you don't have the system, maybe depend on your vendor who can come down and he can take care of the QC management of your equipments. We'll go to the next question.
I think it's very important, Alex, also because for the daily monitoring as well. So it could be that someone accidentally knocks off or changes a setting either by mistake, or thinks that could be a good idea to increase the temperature, doesn't inform the other people in the lab. So all of these situations that you have the human factor influence and accident, someone might accidentally just knock off and switch off the button and turn off the heated stage, and someone might not realize until it's too late. So for all these reasons, it's important to monitor the temperature and not just rely that everything is correct prior to using.
Like maybe one comment I can, because in many places we use the warming incubator and the warm kind of boxes for the test tube heater or something like that. And if it is a local made, I have seen that temperature might going up to the 40 degrees Celsius. Even I have seen some places getting melted. So I think it's ideal. Gaurav, what is your take on that? Ideally, we should keep at least, maybe centers can keep a thermometer in a slot or something like that. They can keep it, that colored thermometer. What is your take on that? This kind of even we can use a thermometer, isn't those low resource centers?
Okay. So I just wanted to say that we've had experiences where people have come in, third party companies have come in to check temperature, and we found that their tools, the tools that they're using in India, are actually past the expiry date for calibration. So not just our own tools have to be calibrated on time, but we should just check whether the third parties who are checking, who are doing quality control for us, also have the right tools. And that's why concomitantly we keep mercury thermometers. It's important to have them in tubes of water, in these test tube warmers, and so we have backup temperature monitoring possibly everywhere.
True, you're absolutely right. I think as a second level of protection, I think we should do that. Yeah. Okay, we'll go to the next question. So there are different systems for pH measurement. What is ideal, or if there is certificate analysis, say pH 7.5 for a single step media, should we follow the same in our lab, or should we bring it down to the physiological pH level for embryos that we are culturing? Because sometimes in the certificate analysis, some months we will see that they are certificate analysis says that what they got is 7.5 for the media that a manufacturer supplied. But we know that there is a small range, it's 7.3 or 7.28 to 7.3 is ideal for the embryo culture. So what is your take on that, George? Can you put a light on that?
We're actually doing a study testing different pHs and whether physiological stem media would be ideal. But in terms of what pH is ideal, I would always go with the manufacturer's recommendations because they've done all the validity studies based on that specific pH. And most manufacturers will have that range somewhere sitting between 7.2 and 7.5. Some will have the same pH throughout the development. Some will go through more physiological changes as they change, as the embryo changes the developmental stage. But whichever media manufacturer, I will always try to comply with their specifications because that's all the validity tests, all the quality assurance comes from that pH that they've tested and is being stable at that level.
Okay. And what is your take on the type of pH measuring systems? What is your take on that?
We did discuss it previously. I mean, we do use the blood gas analyzer for our pH measurements, and now we're installing sensors for pH in our incubator systems. Of course, the system that you have to use has to be calibrated and validated. If you're using a pH meter, just because the blood gas analyzer might be a costly exercise, not just purchasing it, but the cards are also expensive. And if you're going to be testing all the lots and every time you introduce a new gas cylinder, that might be an expensive exercise. So if you're using a handheld pH meter, it is important that you take care of it, you're using the right standards, you calibrate before you use, you change your electrodes often, you make sure that they're kept in the right solution. So all of these steps have to be taken successfully because it's not just taking a measure. You have to be sure that the measurement you're taking is accurate, so your instrument is calibrated and it's working to its capacity in order to be able to take the measurement within your system and then make sure that that reading you're getting is valid.
Thank you. And Gaurava, you would like to add any point on that?
Well, we have struggled with in-house pH meter for long, and for all the same reasons that were just listed by George, that a lot needs to go into maintaining a pH meter. So we are presently now, we are looking at pH only through sending our samples to the ICU and having them tested analyzed in the blood gas analyzer in the ICU, because those are possibly the best devices because they are under a very, very strict quality control. And so every batch of media that we introduce into the lab, we send samples from different media, and we like the pH to be around, even though the media that we use specifies 7.2 to 7.4, but we prefer the pH to be around 7.3 or maximum till about 7.35. So if it's in that range, then we are happy.
Okay, thank you. So there is a lot of discussion on this particular area of what is an ideal pH. So a lot of work is still going on. But for a safety, I think we can culture as per the manufacturer recommendation. And even though there are different systems for a pH measurement, what's ideal, you should train a technician or a person who can do it kind of in a better way, who should be responsible for that. I think, like George said, the electrode is very important. The timely change of the electrode and putting in the solution, KCl solution. Is it KCl? If I'm right?
KCl, correct.
Yeah, I think that's also very important. So these things has to be taken care, especially when the new batch of media comes, you can do that. Okay, right. Okay, this is also related to this same thing. I think we have taken care. Maybe we can avoid that. What else can be done in preventing checking COVID type infection in the lab complex with regard to air handling units, UVC, photocatalytic oxidation based systems, IV workstation, etc., and cleaning strategies? Maybe 1 or 2 points. Then we can go on to the slides by George. George, can you give some kind of insight, since you already started your program after the COVID?
We have started our program, but I have to tell you that the Australian experience is a little bit different than the Indian experience so far, and that has to do with the spread of the virus itself. The measures we have taken mostly focus on limiting positive patients from entering the treatment. So we have done a failure mode and effect analysis to identify what are the risks, and implemented processes to make sure that the patients that come through the clinic for treatment are not going to be positive. That has to do with the country specific. So we have to follow, in Australia, we do follow the regulation of the ATAC code of practice, which basically defines the rules of all our laboratories that work. And we have to minimize patient interaction. So we have tried to minimize interaction with the patient, doing most of the consultations online, doing everything that we can avoid patients physically coming into the clinic. But when they come into the clinic, we ask them to physically take their temperature at home. So not just triaging at the entrance, but making sure that they've taken active temperature measurements at home, which is a more accurate thermometer than the triage thermometers most places use. So therefore, we haven't implemented a lot of change per se in the environment and in the laboratory, just because of the limitation of getting PPEs, and because of the government needs to distribute those PPEs accordingly to higher risk cases when they need it. We've followed our processes as they are. Of course, if the situation changes, and as the situation changes, and it's very fluid, as we're entering here the winter season, we have asked everyone to undertake influenza vaccination as well. Of course, then we might consider taking extra steps in the laboratory. Of course, cleaning and hygiene becomes very important. And of course, most of us embryologists are not used to PPEs and wearing gloves and all of these changes that some of the laboratories have implemented. But I think going into a situation where the spread of the virus becomes an imminent risk, then we have to change our processes. But careful calculation and calculation of risk and mitigation of risk needs to be done.
Okay, thank you. And Gaurav, since Delhi is experienced a lot of cases, since you have started, have you implemented any kind of special systems or the methods, procedures, any disciplinary methods that in your system, any special cleaning strategies? Or what's your take on that?
We've just spaced out the patients. We have spaced them out so that patient interaction becomes less. As far as the embryologists are concerned, now we are having to wear N95 mask, gloves, and basically a disposable gown. So it's, we're not wearing PPE because it's virtually impossible to work while wearing PPE. But still we're covering ourselves, wearing gloves, and we are not leaving any open waste in the laboratory. For every patient, all the fluids, for example, follicular fluid or semen, is all the waste from one patient is immediately put inside one of our disposable bags, sealed and removed from the laboratory. And we are, after anyone who works on any station, we're just securing the place with U-Safe. So that's the cleaning agent which is being used inside the laboratory. So pretty much we just, we spaced out the procedures and we're going slow.
Okay, thank you. So I think we are learning. I think even the Indian societies came together and came out with the suggestions or recommendation or the pre-COVID the IVF practices. So that will be a good documentation for everyone to follow. Thank you very much. And so now we will go to some of the interesting area that may be interesting both of you, since you are doing a lot of biopsies and PGTs. So the question is that day 5-6 embryo biopsies are very common nowadays. And what are some of the issues that arise from these techniques with regard to the laser systems? Maybe you have to troubleshoot sometimes, or the biopsy technique, like the sticking to pipette, or you have to flick sometimes, or it doesn't come out the blastomer from the pipette, or the traceability. That's another thing. Maybe from the biopsy to when the result comes, you have to keep the traceability of the biopsied embryo. So what are the areas? Maybe George can start. What are the areas that you feel one has to be very careful?
There is a lot to think about when doing a day to 5 to 6 biopsy. Of course, we are one of the few clinics that do day 4 embryo biopsy, so it's quite different because it eliminates some of those difficulties that are associated with trophectoderm biopsy. Of course, it has other issues on its own, but in terms of the easiness of the technique changes. But stickiness can be avoided definitely with the addition of protein, and then the flick method itself in terms of the trophectoderm biopsy can create the ease of detachment. Traceability of biopsied embryos is very important. So in our laboratory, we use alphanumerical identifiers in addition to the patient identifiers for each and every embryo that we're using. If there is a doubt that some cells might have been stuck to the pipette, we make sure that the pipette is cleaned thoroughly before we load the next embryo. If we cannot assure that the pipette is clean, then we have to change it. Same when it comes to the loading. We have to always be able to trace those biopsied embryos as we progress. So other than that, the technique itself requires there is a bit of a curve in the learning and how to better manage doing the biopsy itself. So attending workshops, or if you're implementing a new biopsy stage in your laboratory, workshop training, watching videos, visiting clinics can give some insights and some experience into what works and what doesn't.
Okay. So you are doing a lot of day 4 biopsies, I think. What is your outcome experience, kind of the outcome from this compared to the day 5, day 6?
We heard your lecture in Chennai. Where
Yes, I gave a lecture in Chennai about this. So we basically,
I heard about day 4. We were really surprised to see that day 4
we
biopsies can be done.
we decompact the embryos using a calcium magnesium free medium. So they're about to enter the morula stage. So just prior to that, we're decompacting the cells. So it basically mimics the blastomere biopsy that is done on day 3. The difference is that the cell size, it's much smaller, so therefore the opening within the zona is much smaller, and there is 2 ways that we can basically get the blastomeres out. So the benefit of it in comparison to the blastomere biopsy is that you don't only get 1 or 2 cells, you can easily get 3, 4 cells with not inflicting the damage to the embryo and the ability to continue developing to the blastocyst stage. The other benefit of it,
how you make sure that you're not puncturing that or taking out the cell from the inner cell mass area? Is there
it's a good question, Alex. Of course, when it comes to that stage, and I think that's the main reason where a lot of the labs are reluctant in using that technology, is whether we could be aspirating the cells that could thereafter form the inner cell mass. However, there are some studies before we initiated this practice that have shown that that is not the case, and the blastulation rate is actually very good after performing day 4 biopsy. There's even a lot of studies done in, there was a nice paper in Human Reproduction that that showed that even when you take the inner cell mass out of already an expanded blastocyst, the cells of the trophectoderm can thereafter form inner cell mass and express also pluripotency markers. So it just shows you that the embryo can sometimes reprogram. And the fact that we're getting good blastulation makes it suggest that we might not be inflicting so much of a damage and changing in the lineage. So we think that the lineage is not determined completely at that stage. So the results that we get show that even when we don't get a blastocyst the following days, we still vitrify embryos on day 5. And a lot of the embryos we wouldn't be able to biopsy if we were utilizing a blastocyst biopsy approach do give us pregnancies. So that's the benefit of this approach, is that for patients that have low blastulation and high cancellation rate when it comes to the embryo biopsy, it offers them availability of testing more embryos.
Okay.
And I'm not trying to incline people to use day 4 biopsies, but sometimes it could be something to consider. Let's say when you're using a trophectoderm biopsy approach and you have an embryo that it is delayed. So rather than
Okay.
waiting that embryo and culturing for an additional 1 day, and we've seen in studies that now they're doing day 6, even day 7 cultures to get those biopsies done. They could be done without extended culture, but just using a different approach.
So Gaurav, you sent us a lot of PGT biopsies on day 5, day 6. Can you put your views on the system? Yeah.
Sure. I will make, I'll just give 3 or 4 points. So 50% of our biopsies we perform on day 5 embryos, and the other 50% on day 6 embryos. So it's very important for us to culture till day 6, because a huge proportion of embryos, especially in advanced stage patients, they tend to reach blastocyst on day 6. So which means that we almost have to perform biopsy twice for every patient, once on day 5 and once on day 6. So it makes, it's just extra work. Secondly, we like to perform biopsy on blastocysts which have expanded. So we avoid early blastocysts or full blastocysts, and we avoid going in till an embryo doesn't expand. So one of the very important criteria for us to choose an embryo for biopsy is that it has expanded, or it is expanded.
As per the Gardner scoring, it may be more than 3 or 4, something like that.
More than 4. So
it's
around 4, not 3. So we are less inclined to biopsy blastocysts with grade 3 expansion. So we will always wait. That's one of our criteria to decide whether an embryo is ready for biopsy or not.
Right.
So more often than less, we will not choose a grade 3 expansion blastocyst for biopsy. We will leave it for a few hours or until the next day to see if it expands, or if it's grade 5, even better. Early hatching is even better. And so on day 5 morning, when we check embryos, if we have expanded blastocysts, if we have early hatching blastocysts, then those are the embryos that we will take up for biopsy and leave the remaining until day 6.
Okay.
And we make a hole, we create a small, we drill a hole in the zona opposite the ICM on day 5 morning in the embryos that qualify. And then we leave them for 3 to 4 hours, and we allow the cells to herniate out. And that makes the biopsy very quick and very atraumatic, very easy.
Okay.
So that's something that we prefer to do, but it doesn't happen for all embryos. It doesn't. And especially on day 6, where we do not have the luxury of time for, again, creating a hole and again allowing an embryo to herniate. So there we go in immediately. So we create a hole and we go inside the embryo by, pushing in media and displacing the trophectoderm, and then we pluck out a few cells of the trophectoderm. As far as the stickiness is concerned, we like to use less laser. So we are less inclined to using laser, and we try to flick. So we use the flicking technique to excise the clump of trophectoderm from the embryo. So that really works well for us now.
Right. Maybe you can also answer the second but the last question on this one.
Yeah.
Maybe you do
So,
on day 3 or day 4, sorry,
so
hatching, maybe the ICM hatch out, or what is your take on which day is the ideal for kind of hatching the embryo? Is it
yeah,
a
we
day
don't
3,
do
day
this.
4, or you do it on day 5?
Yeah, we do it on day 5. We do not touch the embryo before day 5. So we
Okay.
don't make a hole on day 3 or day 4. And exactly because I said that we are looking for an embryo to expand. And somehow we feel that if a hole is initiated before day 5, then it affects the natural expansion of the embryo.
I also think the same way, because especially when you are traversing or making a hole in the, you're exposing that embryo to the outside environment. And if your the culture system is not optimal, maybe a
Yes.
lot of maybe kind of untoward effect might happen. Even I've seen those centers who does day 3 hatching, even they don't do the biopsy. By the day 5, day 6, you can see a lot of degeneration patches
Yes.
happening on the some of the areas. I think that need to be taken care. I think this is a good strategy for the areas where I think people want to do the biopsies. George, you would like to add something on that?
No, I think you covered most of the aspects of the blastomer biopsy.
Yes.
Perfect.
All right, so I'm just gonna give a brief presentation about how we use tools to troubleshoot. So this is a specific example that I'm going to talk through. So with basically, in order to troubleshoot, we first need to keep an account of our close monitoring of the key performance indicators that we have in our clinic. And then we use those indicators to construct control charts. So this is the first thing, and the first tool I'm going to show is how to construct the control chart. And in order to do that, we get the upper and lower limits, and we present that with the historical mean. So the upper and lower limits are presented with the 2 levels of standard deviations of the mean, because when we do that, we estimate that almost all our values will fall within those 2 standard deviations. So 99.7% of the values will fall within. So it's very easy to construct the control charts in Excel. So the only important thing is to be able to access the data from the database. So that's the tricky thing, and that's what requires to be done. So this is an example that I will use. So it's not our clinical data, it's just an example that I built just for this presentation of how to use control charts for monitoring fertilization rates. So here, let's say, for example, we have the January fertilization rate. So this is for the whole month. And we have these patients coming through for treatment. So let's say this clinic has 27 patients that came through this month. Of course, most clinics will have a higher volume of patients, but this is just for the simple reason of the presentation. So for each patient, we have to have the average fertilization rate. So it's very important that we don't just get all the eggs for all the patients and present how many are fertilized per how many eggs collected for everyone that month, but per patient, because some patients might have, and we have some examples of that, like this example here, we can see the third one had 0% fertilization and the fourth one had 100% fertilization. But it could be that 0% fertilization comes from just 1 egg, or that 100% comes from 20 eggs, or vice versa. So this is why it's important to present it per patient. So we do the same for all the months of the year that have preceded. So it's being presented in a time delineated manner. So we have the rest of the months here, and we have the monthly average that is being generated by all the patients and individual fertilization rates for all the patients. So fertilization rate, of course, for ICSI comes with how many eggs are fertilized based on how many injected. And then we get the mean from all the months that we have the KPIs for. It's also very easy from a function in Excel to get the standard deviation. Then we multiply the standard deviation by 2, And in order to get the upper control limit, then we just basically add the 2 times of standard deviation to the mean. And in order to get the lower control limit, then we basically just subtract the 2 times the standard deviation from the mean. So in order to construct the control chart, we basically highlight the month, the monthly average, then we have the upper control limits, followed by the mean and followed by the lower control limit. And we basically just on Excel command for insert chart and line, and we get the graph. And this is easy to observe. And because we can see the fluctuations from month to month, as we can see for the first few months, there is a little bit of fluctuation. Those fluctuations could be attributed to many different things, and we'll talk about that in the next tool that we're using. But once we see that there is a drop, and that drop is below what we consider to be the lower control limit, then it's important that we then initiate the troubleshooting. And as we can see in this example, after we've initiated troubleshooting, it should be that we identify the source, and then the fertilization rates again fall within what we consider to be close to the mean. So this is a simple example on how to construct control charts. So another tool that it is very useful for troubleshooting is once you've experienced that there is a drop in any of your KBIs, is the Ishikawa fishbone diagram. So basically this diagram is a cause analysis tool that identifies which can be the possible causes that cause these effects. So it can then help us and help everyone brainstorm and find ideas about what could be the possible reasons that can cause this effect. So here we have the effect of the low fertilization. And in each of these different categories, we have things that could contribute to that effect. So it can either be the measurements, the materials, the personnel, the environment, the methods, or the equipment we use. And we should be able to look into each and every one of those components. So this is just some of these things that could be associated with the low fertilization that fall in each to any of those categories, but it could be more. And this is the importance of putting this diagram, is that people can add on of what they consider that other categories or other cause could be associated with that. So for the measurements, for example, we got the KBIs. We have to define, are those KBIs relevant? Was there a shift in patient population? And are we using the correct statistical methods to generate those measurements? And or even other examples that I can just think now, are we using the computer software? Was there an error in inputting the data? Was there mistakes? Did we validate those entry points in the database? Going to the environment, of course, during the webinar, we spend a lot of time talking about those parameters that can affect the fertilization. And then the methods. So when we have the methods, we have to review the SOP. We have to do an internal audit. Does everyone know the SOPs? Everyone following the steps that are required in terms of the denudation, in terms of the microinjection? Are all these steps followed? The materials itself, are they toxic? Is the media stable? Did we allow the plastics to off-gas and avoid buildup of plasticides? These are just examples, but there could be other things that could also contribute. Then we have the staff. We have to monitor staff performance, and we did talk a little bit, even this Q&A, about how staff performance can be observed. But is it also a matter of the staff being overworked and or cutting corners and not doing the QC properly? Does everyone have adequate training? All the staff have qualifications, and do we assess the competency? Do we have direct supervision? Do we assess them formally? Do we track the statistics of each individual? So all of these are important. And of course, the equipment itself, is the equipment underperforming? Have we tested the efficiency of the equipment? Do we do the preventative maintenance to make sure that they're working according to their specifications? And of course, use of calibrated and validated instruments for monitoring the equipment. So these diagrams are very useful in terms of brainstorming and finding causes. And of course, troubleshooting takes into account each and every one of those to try and pinpoint the exact cause for that effect. Thank you.
Thank you, George. I'm going to definitely use that diagram now, henceforth.
So that was very interesting. I think we have the last session, we have pinpointed a specific areas of troubleshooting, but I think this is very important. I think everybody in the laboratory or the senior person should know what are the tools they can use to troubleshoot with the statistical processes. I think with Excel, I think we can do many of these short chart or the Levy-Jennings chart kind of control charts. It's very easy to do. Even I think, and now some kind of online, you can also do this thing. I heard that the Fertilization by James Stanger in Fertilization in Australia, I think they are doing a lot of KPI kind of as a part of external monitoring. They are also planning to do this kind of things for the clients. Maybe that's very interesting. Like you said, you have given example of effective low fertilization. At this point, maybe people can put different areas, maybe why the fragmentation, why low pregnancy rate. Then you have to go back to the fishbone and put different areas, cause effect analysis. I think that's very interesting. So that's become very complex area you can look into to troubleshoot. Interesting.
So George, I want to ask you, so this fish, what's it called? The fishbone diagram. This will pretty much apply to troubleshooting all different KPIs, right?
Yes, it will do. Of course, in every category, different things can go into. And even in this category, even for this specific problem, other things can go in it that are specific to each and every different laboratory and environment. So of course it can be used in any setting, and in any KBI, and you have the effect. Here is the low fertilization. It could be a different effect. It could be that the main categories might be the same, or they might shift depending on the problem in place.
So you would suggest, suppose somebody is starting a new clinic, maybe they should have this kind of a flow chart or a system or kind of a process map in place, so that later on when they somebody come across some kind of problem, they can look into this chart and they can pinpoint. That is what you want to say?
Of course, it's important to have in place, and I know document control might become a little bit difficult for some of the laboratories, but in situations when there is issues, then having processes in place and having risk assessed and solutions for possible problems can go a long way in trying to resolve situations and have uniformity in how you deal with problems. And of course, problems do arise in the laboratory settings, and during these two sessions we've covered, I think, an abundance of different issues that we can encounter. So the more understanding of the processes and the more processes in place to deal with this situation, I think the better it is to get out of any given situation, in any problem, without jeopardizing the cycle outcomes for the patients.
Okay, all right. Gaurav, you would like to comment or you want to say anything?
No, so I completely agree with him.
Okay.
And this has been, it looks like a very useful flowchart. And like I said, henceforth, I'm going to refer to this, and I'm going to apply this in my laboratory.
Good. Yeah. So I think we can wind up today's session. It was a good discussion of the two webinars. We started with the first webinar looking into different areas, and we had Dr. Laura, Ronnie, George, and Lars Gaurav, and myself taking different areas that we discussed. And this session we took a lot of questions, and the best thing of this day's session was the tools that we discussed. I think many people will benefit from. I'm sure that many people will benefit from this the statistical process as part of the quality assurance schemes. So here we would like to stop our today's webinar, and thank you, George and Gaurav, for actively taking part and taking your time from your busy schedule. I know it is late, almost midnight there in Sydney, isn't it? It's
Yes, it is, but it has been a pleasure, Alex. Thank you for this. Thank you, Gaurav, for moderating and for this interesting discussion.
Okay, thank you very much.
Thank you very much. It was our pleasure, and it was my pleasure to be part of this. Thank you very much, Alex, and thanks.